All right, today's notes are on composite functions. You can go into Google Classroom and into your notes and print out the blank form. It has the steps on there. It's got all the problems written down. We're not going to do problem number 5, similar to some of the other ones. All right, the warm-ups should help you with understanding these problems. Composite functions are just a combination of functions, 2 or 3 functions combined into one. So I have these 3 functions, f of x, g of x, and h of x, and we want to compute the following. All right, so according to these notes, evaluate the inside function first. So these things can be written either way. These are composite functions, and they're both read f of h of 7. This is just another way of writing it. That's a circle, not a dot. F of h of 7. So the first thing we do is we figure out what the value of this is. Okay? So evaluate the inside function first. So I want to take my function h and evaluate it at 7. So just like in the warm-ups and just like we've done before, wherever you see an x, replace it with a 7. And then just follow your order of operations. I square the 7 first, add the 1, that's 50. Okay, so there's step 1, evaluate the inside function. Substitute this value into the outside function. My outside function is the function f, so now I'm going to evaluate the function f at 50. So wherever there's an x in 50, or an x in f, I replace it with a 50. So that would be 100 minus 1, or 99. And that answer is the final answer, 99. So f of h of 7 is 99. So the same thing on this one, number 2. The first thing I do is the inside function, f of 3. So I take my function f, and I evaluate it at 3. Here's my function f. Instead of an x, I put parentheses, and the number that goes in there is this number right here. So that would be 6 minus 1, which is 5. And all I did was I evaluated f of 5, or f of 3, sorry. So I can replace that f of 3 with a 5. They're the same thing. And now I find the function g evaluated at 5. So just make sure you use the right function. The function g is 3 times x. And in place of that x, I put a 5. So the answer to that is 15. So g of f of 3 is 15. And like I said earlier, you could use 1 function, 2 functions, 3 functions. This way I put in here continue if necessary. This one, I'll always start inside here. So I'm going to evaluate the function g at 2. So wherever I see an x in the function g, I replace it with a 2. So that's 6. So this thing right here could be replaced with a 6 because they're the same. So now I evaluate the function f at 6. Okay, I evaluate this second. So I take my function f. There's my function f. And I replace the x with a 6. So that'd be 12 minus 1, or 11. So this whole box now can be replaced with an 11. So now what I want to do is evaluate the function h at 11. So here's h at 11. Whatever I get here should be my final answer. So it'd be 11 squared plus 1. 11 squared is 121. Plus 1 is 122. So my final answer to this problem, h of f of g of 2, is 122. It doesn't really matter what I put inside there. That goes into that function, just like on this one. Notice this is f of 2x minus 3. So I'm going to write down my function f. Here's my function f, the original function f. In place of the x, I put parentheses. Now I just take this value right here, substitute it in for x. Again, doesn't matter what that is. That could be happy face. I'd put a happy face there. So I distribute and I get 4x minus 6. Put the minus 1 back in. Combine your like terms, simplify, put it in standard form. So I get 4x minus 7. Okay, like I said, we're going to skip number 5. That's similar to 2 and 3. All right. Now this one, notice there's nothing replaced the x. So all I can do here is put the function h. Here's my function h. Okay, it's h of x, and h of x in the directions was x squared plus 1. That's all I can do right now. Now, just like number 4, I take the function f, and wherever there's an x, I'm going to replace it with, in this case, x squared plus 1. So I distribute the 2, and I'll get 2x squared plus 2 minus 1. Combine my like terms, I get 2x squared plus 1. And then the last one, again, this notation is the exact same thing as g of f of x. It's just another way of writing it. So I do this first. But there's nothing to do there. There's nothing to replace the x with, so I can replace the f of x with the actual function, which in this case is 2x minus 1. Now I take the function g. Here's the function g. Instead of an x, I put parentheses, and I place that 2x minus 1 in the parentheses and simplify as much as we can. So this one is just distribute the 3. Those are not like terms. It cannot be combined, so that's it. That's composite functions. Now I can make them a little more complicated. You look on your homework, there's square roots, there's squares. I had a square in these examples, but the process is the same. Follow these notes. Evaluate inside out. All right, hopefully that'll help. Good luck on your homework.